Dear students, now we are going to the recurrence relations of Bessel functions. So what is the recurrence relation? First we are going to what is d by dx of x to the power n jnx. This is the first recurrence relation. D by dx of x power n jnx equals x power n into jn minus 1x. X to the power jn equals d by dx of x to the power jn equals x to the power n jn minus 1. How to prove? So its proof is, we know that what is jnx? Jnx equals sigma r ranges from 0 to infinity minus 1 to the power r x by 2 all to the power 2r plus n all divided by r factorial into n plus r factorial. This is jnx. Jnx is sigma r ranges from 0 to infinity minus 1 power r x by 2 all power 2r plus n all divided by r factorial into n plus r factorial. So what is d by dx of x to the power n jnx? Then d by dx of x to the power jnx equals, it is sigma r ranges from 0 to infinity minus 1 to the power r divided by this r factorial into n plus r factorial into, again there is a term 2 power 2r plus n into, what remains there? It is d by dx of, there is x power 2r plus n into x power n. So it is x power 2r plus 2n. D by dx of x to the power 2r plus 2n. So which equals sigma r ranges from 0 to infinity minus 1 to the power r by r factorial into n plus r factorial into 2 to the power 2r plus n. What is the derivative of this one? That's again 2r plus 2n into x to the power 2r plus 2n minus 1. Agree? X to the power 2r plus 2n minus 1. So that is rearranged as, it is sigma r ranges from 0 to infinity. There is minus 1 power r, and on numerator it is 2 into r plus n, all divided by, it is r factorial into n plus r factorial into 2 power 2r plus n into, this can be rewritten as x to the power 2r plus, or it is again x to the power 2r plus 2n minus 1. Here there is 1, 2 and 2 cancelling each other. R plus n and n plus r cancelling each other. So n plus r factorial, 1 n plus r cancelling each other. So this can be rewritten as, it is sigma r ranges from 0 to infinity. It is again minus 1 to the power r divided by, there is r factorial into 1 r plus n cancelling each other, remains n plus r minus 1 factorial into, on denominator it is 2 power 2r plus n minus 1, 1, 2 cancelling each other, and this can be rewritten as x power 2r plus n minus 1 into x power n. 1 x power n can be rearranged as in that way. That is nothing but this x power n into, what about this term? That is jn minus 1x. Why? Jn minus 1x is sigma ranges from 0 to infinity minus 1 to the power r. It is x by 2 all power 2r plus n minus 1 by r factorial into n plus r minus 1 factorial. This is nothing but jn minus 1x. So this is our first recurrence relation. D by dx of x to the power n jnx is nothing but x power n jn minus 1x. Agree? Similarly, we can prove the second recurrence relation. The second recurrence relation is d by dx of x power minus jnx equals minus x power minus n jn plus 1x. This is our second relation. D by dx of x power minus n jnx is minus x to the power minus n jn plus 1x. How to prove? Here again, what is jnx? We know. What is jnx? Jnx equals sigma r ranges from 0 to infinity minus 1 power r. It is x by 2 all power 2r plus n all divided by r factorial into n plus r factorial. So, it is d by dx of, this implies d by dx of x power minus n jnx equals, it is sigma r ranges from 0 to infinity minus 1 power r. There is x power 2r plus n into x power minus n. There is only x power 2r all by r factorial n plus r factorial, and again there is a 2 power 2r plus n. What remains there? There is x power 2r plus n into x power minus n. X power 2r remains, so it is d by dx of x power 2r, which is nothing but sigma r ranges from 0 to infinity minus 1 power r. Derivative of this one is 2r into x power 2r minus 1 all divided by r factorial into n plus r factorial into 2 power 2r plus n into x power, there is x power 2r into x power 2r minus 1 into this one. So 1 2 cancelling each other and 1 r cancelling each other. But if you cancelling this r in r factorial, there is a term on denominator which is r minus 1 factorial. This, but r ranges from where to where? 0 to infinity. When r equals 0, it is minus 1 factorial. So r minus 1, when r equals 0, r minus 1 factorial is nothing but infinity. That is minus 1 factorial. So when r equals 0, r minus 1 factorial goes to infinity. So that gives some practical difficulties. So we can exclude this r equals 0. So this can be rearranged as sigma r ranges from 1 to infinity. Why? Because this sum is infinite. So it is r equals 1 to infinity minus 1 power r, 1 2 cancelling each other, x power 2r minus 1 all divided by r and r factorial. So it is r minus 1 factorial, again n plus r factorial, and in terms of 2 power 2r, 2 and 2 cancelling, so 2 power 2r plus n minus 1. Okay, so put r equals m plus 1. Put r equals m plus 1. When r equals m plus 1, since it is an infinite sum, when r equals m plus 1, so when r equals 1, what is m? M goes to 0. So this sum becomes sigma m ranges from, it is sigma m ranges from 0 to infinity minus 1 power m plus 1, r is m plus 1, x to the power 2 into m plus 1 minus 1 all divided by m plus 1 minus 1 factorial into n plus r factorial into 2 power 2 into m plus 1 plus n minus 1. That is nothing but sigma m ranges from 0 to infinity minus 1 power m plus 1 2m plus 2 minus 1, that is x power 2m plus 1, all divided by 2m plus 2 minus 1, 2m plus 1 by, it is m factorial into n plus r. What is r? R here m plus 1. So it is n plus m plus 1 factorial into 2 power 2m plus 1 plus n minus 1. So it is 2m plus n plus 1. Okay. So it is minus 1 to the power m plus 1, x to the power 2m plus 1 by m factorial n plus m plus factorial into 2 power 2m plus n plus 1. Okay. So this can be rearranged as, this is nothing but minus 1 into sigma m ranges from 0 to infinity, which means there is minus 1 power m into x power 2m plus n plus 1. Why? Because there is 2 power 2m plus n plus 1. There is x power n introducing. You can simultaneously introducing x power minus n there. Okay. By m factorial into n plus m plus 1 factorial into 2 power 2m plus n plus 1. So that is rearranged as, put this x power minus n again goes outside, that equals minus 1 into x power minus n into sigma m ranges from 0 to infinity minus 1 power m x by 2 all power 2m plus n plus 1 all by m factorial into n plus m plus 1 factorial. What is this one? That is jn plus 1. So this is nothing but minus x power minus n jn plus 1x. This is what we require here. So derivative d by dx of x to the power minus n jn x is minus x power minus n jn plus 1x. So these are the two recurrence relations. One is d by dx of x power minus n jn x is this one. Sorry, x power minus n jn x is this one. And the second one is d by dx of x power n jn x is x power n jn minus 1x. Okay.